The Seven Daughters of Eve, 2001, by Bryan Sykes, is part nonfiction, part historical fiction, a book that introduces the science of human mitochondrial genetics to a general audience while imagining the lives of our distant ancestors. Sykes, professor of human genetics at the University of Oxford, has been involved in several high-profile cases concerning ancient DNA, including the now-debated identification of Cheddar Man. He begins the book by breaking down the basics of DNA for non-specialists, describing it as life's blueprint, the repository of genetic information essential to growth, development, and reproduction. From there, he moves into genetics more broadly, how traits pass from one generation to the next, and the evolutionary journey of humankind over hundreds of thousands of years. This scientific foundation prepares readers for his focus on mitochondrial DNA, a key subject of the book. Mitochondrial DNA, as Sykes explains, is inherited exclusively from the mother, not the father. Because of this, it provides scientists with a unique way to trace maternal lineages back through countless generations, connecting each mother to the next in an unbroken chain. By studying small variations within mitochondrial DNA across individuals, Sykes has been able to reconstruct ancestral lines and group people by shared maternal heritage. He illustrates this with examples from his own work. In one case, he investigated the origins of modern hamsters, hypothesizing they all descended from a single female caught in Syria in 1930. By contacting breeders and collecting fecal samples, he confirmed his suspicion. Every hamster he tested carried identical genetic markers pointing to one recent ancestor. In another famous case, in 1991, he used DNA analysis to confirm that remains found in a mass grave in Russia were those of Tsar Nicholas II and his family. His research also demonstrated that Polynesians traced their lineage back to Asia rather than South America, disproving Thor Heyerdahl's theory of a Peruvian origin. Building on these studies, Sykes introduces the central argument of his book, that nearly all Europeans descend from one of just 7 women, the 7 Daughters of Eve. Each represents a distinct mitochondrial haplogroup, defined by characteristic mutations within mitochondrial DNA. These women lived in different prehistoric eras but ultimately shared a single common ancestor, mitochondrial Eve. At this point, Sykes blends science with creative license, giving each ancestor a name to make them more relatable. Ursula, haplogroup U, Xenia, haplogroup X, Helena, haplogroup H, Velda, haplogroup V, Tara, haplogroup T, Katrine, haplogroup K, and Jasmine, haplogroup J. His findings challenged long-held assumptions that Europeans had replaced earlier populations during the Stone Age. Instead, mitochondrial evidence indicates that many modern Europeans are direct descendants of people who have lived on the continent for tens of thousands of years, some as far back as 45,000 years. These ancestors were already present in Europe well before the agricultural revolution, during the deep history of hunter-gatherer societies. In the final portion of the book, Sykes turns from science to imagination. Beyond simply naming the 7 women, he invents stories about their lives, settings, and struggles in prehistoric times. These passages, however, are highly speculative, since no written or material evidence exists to reconstruct such details. Reception of the 7 Daughters of Eve was mixed. While many praised Sykes for simplifying complex genetic science and presenting an accessible theory, critics found fault with the speculative reconstructions and noted the narrow scope of his claims. By limiting his analysis to Europe, he ignored other lineages across the globe. The Guardian, for example, suggested there are closer to 33 Daughters of Eve worldwide. Furthermore, later genetic discoveries have refined or superseded some of his conclusions. Sykes revisited the topic in Blood of the Isles, expanding his research by incorporating both mitochondrial DNA and paternal Y chromosome evidence to trace the genetic history of the British Isles. Thank you for watching. If you enjoy this video, leave a like and subscribe.